Okay, this is the first revision video for C1. We're going to look at fundamental ideas of chemistry. So the first fact we need to be confident on is that all substances are made of atoms. Okay, atoms are the smallest part, but we do actually need to know the structure of the atom as well itself. And elements are made up of one type of atom only. Okay, and those elements we can find on the periodic table. You will take in a copy of the periodic table with you to the exam, so it's really important that we know how it's laid out and we know how to understand it. And there'll be a separate video just on looking at your data sheet for the exam. So if you're not sure on that, then have a look at that separate video. So we can see that the periodic table is arranged in these columns here, okay? And there are particular ones that you need to be aware of for your exam. You need to know that group 1 is the alkali metals. You need to know the central block here are called the transition metals. Group 7 are the halogens, and 0 at the end, or sometimes called 8, are the noble gases, and we'll look at those in particular in a second. This red stair line here divides the metals on this side of the periodic table from the non-metals on this side of the periodic table. So again, there's no reason you can't draw that on your periodic table in the exam. So it starts underneath boron and goes down like a staircase, but again, that will be gone through separately in a whole separate video looking at the data sheet for the exam. So that is the periodic table, which contains all the elements, and elements are made up of only one type of atom. Elements in the same group of the periodic table, so the alkali metals, the halogens or the noble gases, have the same number of electrons in the outer shell. And that's really important because what it means is they therefore have very similar properties. So for example, the noble gases are very unreactive, and the halogens are quite toxic, and the alkali metals are really, really reactive. So it's the fact that they have the same number of electrons in their outer shell, which means they have the similar properties. So group 1 have 1 electron in their outer shell, group 7 have 7 in the outer shell, okay? And these atoms on the periodic table are represented by chemical symbols. So what you'll see on your data sheet is you'll see the symbol, so for example O, and then oxygen written underneath, and for sodium it's Na. So the letters on there will represent the elements. An atom, you should be familiar with the structure of an atom. So it's made of a central nucleus with protons and neutrons, and the electrons orbiting the nucleus in shells. Okay, and you need to know the charges of those. So protons are positive, that's a positive charge in the nucleus. Neutrons have no charge at all. So overall, the nucleus is positive, and in the shells around the outside, you've got negative electrons. So negative electrons orbiting that positive nucleus. But overall, what's important to remember is the number of protons always equals the number of electrons. So overall, an atom has no charge at all. So if we have 12 protons, we'll have 12 electrons. So that means 12 protons, that's 12 positives, and we'll have 12 negatives, 12 negative charges. So overall, that will be 0. So 12 take away 12 is 0. So an atom on the periodic table has no charge at all overall, even though it's made up of charged subatomic particles, things with inside it. You may be asked to draw the atomic arrangement or structure of an atom in your exam. So for sodium, sodium has 11 electrons, and again you can find that on the periodic table. If you're not sure how to, then go to that separate video, and you can see that it's got 11. Okay, so what we need to do is work out how to draw these 11 electrons on these shells. The first shell is only small, so I can only fit 2 electrons in there, and that shell is now full. So I've got 2, I need to get to a total of 11. I can fit 8 in the next shell, and I'm not going to need to put all 8 in there because that's going to make 10 in total. 1, 2, 3, 4, 5, 6, 7, and 8. So that's 10. And I said sodium had 11, so I need to put 1 more on the outer shell. So that's sodium, 2 in the first, 8 in the second shell, and 1 in the third shell. If I was asked to write the electronic configuration of sodium, it'd be 2 for 2 in the first shell, followed by an 8, followed by a 1. And that's the number of electrons and how they're arranged in the shells for sodium. So you'll also get these here. You can see what I've already said then on the periodic table. Here's your symbol, here are two numbers, top and bottom. So you've got the sum, the top number is the mass number, the sum of the protons and neutrons, that's the mass number, and the bottom number is the atomic number, the number of protons. So this is helium, He is helium, it has a 4 at the top and a 2 at the bottom. So this mass number, the sum of the protons and the neutrons, is telling us what's in the nucleus, this big block here. So it's told me there's 4 things in the centre there, and there are 2 of those are protons. So 4 is the number of protons and neutrons added together, and 2 is just the number of protons. I'd do 4 take away 2, which would give me 2 neutrons. And I've told you already that the number of protons always is the same as the number of electrons. So if I've got 2 protons, I must have 2 electrons. Okay, so that's how to interpret that symbol and the relevant numbers next to it, the mass number and the atomic number, and to get the information from that diagram. So there's a couple of groups we need to talk about, in particular on the periodic table. And the first one is group 1, the alkali metals. These are really, really reactive metals, very violently reactive. And it does specify on your specification that you need to be familiar with the reactions for oxygen and for water. So if I have an alkali metal and I react it in oxygen, I'm going to get the metal oxide. So for example, if I took lithium from group 1, I reacted it with oxygen, so burnt it in air, it reacts with the oxygen in the air, it's going to make lithium oxide. And you may have to write out that word equation in your exam. If for water, I've got alkali metal plus water, so water is H2O. So I no longer just have oxygen like here, I also have hydrogen. So I don't just make a metal oxide, I make a metal hydroxide this time, plus hydrogen is left over as well. Because remember it's H2O, so I've got 2 lots of hydrogen in my water, so I get a metal hydroxide and hydrogen gas being given off. Remember the test for hydrogen gas is a squeaky pop, so if you put in a lit splint and it pops, that's a test for hydrogen. So they're the 2 types of word equations you may be asked to write down when you're looking at the alkali metals. And the other group is group 0, which are the noble gases. And like I said, they're really unreactive, okay? And the reason they're unreactive is because they have what's called stable arrangements. This outer shell in a noble gas is full. So it either has 2, if it's helium, or the others underneath, so this would be helium up here with 2, all these others underneath all have full outer shells, which would be 8. So they don't need to get or steal or borrow or share any electrons for outer shell. It's completely full, so they're stable, they don't need to react with anybody. So you may be asked why noble gases are unreactive. It's because they have stable arrangements or full outer shells. Okay, so we've looked at the fact that substances are made completely of atoms, and the elements are made of only one sort of atom. And the elements that you need to be aware of and that we've discovered are in the periodic table. Okay, and the elements in the same group, so if we look at group 5, would have the same number of electrons in the outer shell. So elements in group 5 will have 5 electrons in the outer shell, meaning that they have similar properties. We know that atoms are represented by symbols on the periodic table and can be drawn like this, so protons and neutrons in the nucleus and electrons going around the outside in shells. And we may be asked to draw the number of electrons in the outer shell using the information from the periodic table. So we may be given something that looks like this with a mass number and atomic number, and from that we may have to work out how many electrons it's had, which is just the bottom number, and we might have to draw those onto the diagram. And then we've looked at alkali metals and noble gases as 2 examples of groups in the periodic table. Okay, so that's the end of the first part of C1.